Imagine looking up at the night sky and feeling a rush of excitement as a brilliant streak of light darts across the heavens, a harbinger of change in the cosmic arena. Recently, scientists caught a glimpse of an unprecedented celestial phenomenon, a mysterious burst of energy emanating from Mars itself, as if the red planet were sending us a message. This unexpected signal, captured by a network of advanced space telescopes, has ignited debate and wonder among experts and enthusiasts alike. What could this burst mean for the future of space exploration? And is it a sign that Mars is ready for a new era of human colonization? In the midst of our busy lives on Earth, the idea of reaching out to another planet has always felt like the stuff of dreams. Yet, here we are on the brink of an extraordinary chapter in human history, where the possibility of living on Mars is no longer a distant fantasy, but a tangible goal. The signal from Mars has stirred emotions that mix hope with trepidation, a call to action that resonates deep within our collective imagination. It poses a compelling question: who among us will be brave enough to lead the charge in colonizing the red planet? This moment in time, charged with cosmic mystery and human ambition, sets the stage for an ultimate space race. With every new discovery, our understanding of Mars deepens, and with it, the stakes of the competition to claim its barren yet captivating surface. The question lingers, inviting us to explore the unknown, as nations and private enterprises gear up for this monumental challenge. Who will ultimately pave the way for humanity's next great frontier? Our fascination with Mars is not a sudden infatuation, but the result of decades of exploration, observation, and scientific breakthroughs. For many years, Mars has intrigued scientists and dreamers alike. A mysterious neighbor with a rusty, barren surface that hints at ancient rivers and perhaps even water beneath its crust. The story of Mars is one of gradual discovery, from the first telescopic observations in the 17th century to the mid-20th century race to send satellites and, eventually, landers and rovers to the planet's surface. Each mission has added a new layer to our understanding of its geology, atmosphere, and potential for life, setting the stage for today's monumental discovery. Recent advancements in technology have dramatically enhanced our ability to study distant worlds. Innovations in orbital telescopes, sensitive detectors, and powerful data processing algorithms have allowed scientists to sift through cosmic signals with unprecedented precision. When a mysterious burst of energy was recently detected emanating from Mars, it was like an echo from the planet's hidden depths, a signal that could point to previously unknown geological or even atmospheric processes. Imagine it as an unexpected heartbeat in an otherwise silent cosmos, sparking questions about whether Mars might be more dynamic and potentially hospitable than we once believed. This new discovery comes on the heels of a rich legacy of exploration that has continuously pushed the boundaries of our knowledge. Early space missions, fueled by both political ambition and human curiosity, turned the theoretical into the tangible. The pioneering work of those who first sent humans to the moon set in motion a relentless drive to conquer the final frontier. With each successive mission, our understanding of space has deepened, and what once was considered science fiction has steadily transitioned into the realm of possibility. Moreover, the burst of energy has injected fresh urgency into the long-standing competition to colonize Mars. It has stirred debates not only among scientists, but also among nations and private enterprises about who will seize the opportunity to lead humanity into this next chapter of exploration. The discovery is a reminder that our journey toward Mars has been built on the cumulative efforts of countless researchers and engineers who dared to dream big. In essence, the event marks a significant turning point, one that builds on a rich, historical foundation while hinting at the transformative potential of future discoveries. As scientists and space enthusiasts around the world continued to analyze the mysterious burst of energy from Mars, the initial excitement began to give way to a mounting sense of urgency and disbelief. In laboratories and control rooms, teams of researchers huddled around screens displaying complex graphs and pulsating data, their faces illuminated by the cold glow of computer monitors. Each new set of measurements seemed to confirm that what was once thought to be a random, isolated phenomenon was actually part of a larger, more intricate pattern. The burst was not a singular event, but appeared to be the first overture in a symphony of activity emanating from Mars, hinting at an underlying process that defied everything we had previously understood about the red planet. With every passing hour, as additional telescopic data streamed in from orbiting satellites and deep space probes, the initial questions evolved into more profound mysteries. What mechanism on Mars could produce such a phenomenon? Could this be evidence of previously unknown subsurface activity, or even, against all odds, the faint pulse of a hidden biosphere? The intensity of the situation escalated when subsequent observations revealed that the energy burst was not only recurring, but also increasing in magnitude. Researchers began to notice subtle changes in the Martian atmosphere and magnetic field that coincided with the timing of the bursts. Some experts proposed that these changes might be linked to geological shifts deep beneath the planet's surface, movements that could, over millennia, reshape the landscape of Mars. Others speculated that the activity might be driven by a more exotic force, one that challenged our conventional theories of planetary science. In a flurry of excitement and apprehension, international space agencies and private aerospace companies scrambled to reallocate resources and adjust their mission plans. The burst had inadvertently become a catalyst for a new wave of collaboration and competition in the quest to understand Mars. As high-stakes discussions unfolded in boardrooms and scientific conferences, the global community found itself at a crossroads. Continue to view Mars as a static relic of our solar system's past, or embrace the possibility that it was a dynamic world with secrets yet to be uncovered. Behind the scenes, the human element of this cosmic drama added a layer of tension that was as palpable as it was unpredictable. Seasoned astronomers who had once expressed cautious optimism about the prospects of colonizing Mars now found themselves wrestling with ethical and existential dilemmas. The prospect of uncovering potentially groundbreaking natural processes was thrilling, yet it also carried an unspoken warning. The power to reshape our understanding of life in the universe could also come with unforeseen risks. Some scientists voiced concerns that tampering with, or even simply observing these phenomena, might disturb a delicate balance on the Martian surface, a balance that, if disrupted, could have cascading effects on any future human settlement. Their debates, filled with a mix of scientific rigor and raw emotion, resonated far beyond academic circles. In living rooms, cafes, and social media feeds, the public buzzed with speculation and anxiety, each new headline fueling both wonder and trepidation about what might come next. As the scientific community delved deeper into the mystery, one thing became increasingly clear. This was not a fleeting event, but rather the opening act of a larger cosmic narrative with profound implications for humanity. The world watched as researchers from rival organizations began to share preliminary findings, each trying to piece together the puzzle while guarding their own hard-earned data. In this high-stakes game of discovery, every piece of information was like a precious artifact, offering a glimpse into Mars's hidden story. International collaboration, once hindered by bureaucratic boundaries and competitive interests, now teetered on the brink of a new era. The question that loomed large was not only about understanding the burst itself, but also about who would have the authority and capability to lead humanity's next leap into the unknown. In the midst of this scientific frenzy, visionary engineers and ambitious entrepreneurs began to sketch out bold plans for manned missions to Mars, each proposal laden with the promise of turning the red planet into a new frontier for human civilization. The burst of energy, mysterious and awe-inspiring, had transformed Mars from a distant, unchanging world into a dynamic theater of natural phenomena, a stage where every geological quiver or atmospheric fluctuation could signal the beginning of an entirely new chapter in planetary science. The stakes could not have been higher. Not only did this discovery challenge our fundamental understanding of Mars, but it also ignited a competitive spark that could redefine the geopolitical landscape of space exploration. Governments and private entities alike were now in a race against time, their ambitions fueled by the tantalizing possibility that this event was the harbinger of conditions favorable for colonization. With each passing moment, as the data grew more compelling and the stakes higher, the mystery deepened. How exactly would these bursts influence Mars's long-term evolution? Could they be harnessed or even predicted in a way that would make a sustainable human presence feasible? And perhaps most provocatively, what did it mean for the future of our own species? The discovery had thrown open a door to a world of possibilities and dangers that no one could have foreseen. In the charged atmosphere of scientific inquiry and human aspiration, every unanswered question added to the palpable suspense. As the tension built and the narrative of Mars's transformation unfolded, one thing was certain: the journey to understanding this cosmic signal was only just beginning, and its ultimate revelations promised to reshape not just our view of Mars, but our entire place in the universe. Then, on an otherwise unremarkable morning at a state-of-the-art research facility nestled in the heart of a bustling space center, the breakthrough that everyone had been waiting for finally emerged. For months, teams of scientists and engineers from around the globe had been poring over streams of data, running complex simulations and cross-checking observations from orbiters, landers, and telescopes. What they discovered defied every expectation. The mysterious bursts of energy from Mars were not random, isolated phenomena at all. Instead, they were the rhythmic pulses of an intricate network of geothermal vents hidden beneath the planet's scarlet surface, a discovery that could revolutionize our understanding of Mars and its potential to support human life. In the dimly lit conference room, the air crackled with anticipation as Dr. Elena Ramirez, the lead planetary geologist, stepped up to the projection screen. Her voice trembled slightly, with a mix of excitement and reverence as she detailed the evidence. For the first time in our exploration of Mars, we have direct proof of active subsurface processes, she declared, her words resonating with the gravity of the moment. These bursts are not mere flares or magnetic disturbances. They are the signatures of thermal vents, channels that carry heated fluids from deep within Mars's interior to its surface. As she spoke, vivid images of underground channels and pulsing hotspots filled the screen, each frame a testament to the planet's hidden dynamism. The revelation sent shock waves through the room. Here was concrete evidence that Mars was far from the cold, lifeless rock many had assumed it to be. Instead, its interior harbored pockets of energy, pockets that could create localized environments warm enough to support not just microbial life, but potentially even serve as natural energy sources for future colonists. Dr. Ramirez continued, explaining that these geothermal vents had been long theorized but never before observed with such clarity. We're looking at a planetary engine, one that could provide both heat and energy, she said, her tone a blend of scientific precision and palpable wonder. This is a game changer. If harnessed correctly, these vents could power habitats, drive industrial processes, and even be integrated into life support systems. As the gravity of the discovery settled in, international news outlets began to buzz with headlines proclaiming Mars as a living planet, with untapped resources beneath its surface. Scientists from rival organizations who had once competed for the limelight suddenly found themselves pooling their data and theories in a race not just for discovery, but for the very future of human space exploration. Satellite images and spectral analyses from orbit revealed that these geothermal hotspots were not isolated incidents. They formed an extensive network that spanned a vast region of the Martian equator. The interconnected nature of these vents suggested that beneath Mars's rugged terrain lay a labyrinth of warm, fluid-rich channels, a subterranean web that could be the key to sustaining life in an otherwise harsh environment. In laboratories around the world, researchers reanalyzed every piece of available data. Instruments designed to detect minute variations in temperature and magnetic fields picked up consistent signals corresponding to the vent activity. Advanced computer models simulated the fluid dynamics of Mars's interior, confirming that the observed energy bursts were indeed the natural byproducts of an active geothermal system. In one particularly dramatic moment, a team at the European Space Agency's research hub watched in stunned silence as their latest simulation rendered a vivid, three-dimensional map of Mars's hidden plumbing. The map revealed that the vents could potentially be interconnected with underground reservoirs of water, a discovery that hinted at the tantalizing possibility of microbial ecosystems thriving in the Martian depths. The discovery not only redefined Mars as a dynamic and evolving world, but also posed profound questions about its capacity to support human habitation. For decades, colonization plans had centered on terraforming a planet that was assumed to be inert and inhospitable. Now, the idea of tapping into Mars's internal energy sources opened up entirely new avenues for sustainable settlement. Engineers began drafting designs for habitats that could be built near these geothermal hubs, where natural heat could reduce the need for artificial warming and energy production. Proposals emerged for self-sustaining colonies that would rely on the planet's own resources, a symbiosis between human ingenuity and Martian nature that had never before been contemplated. Amid this flurry of scientific progress and technological innovation, ethical debates surfaced, underscoring the weight of the discovery. Some scientists cautioned that interfering with Mars's natural processes could have unforeseen consequences. What if tapping into these geothermal systems destabilized the planet's delicate internal balance? Others argued that the potential benefits far outweighed the risks, envisioning a future where humanity not only survived on Mars, but thrived by harnessing its natural energy. As policymakers and space agency leaders convened emergency meetings, the discussion shifted from pure scientific curiosity to a broader conversation about humanity's destiny among the stars. In one of the most stirring moments of the day, a joint press conference brought together leading figures from NASA, ESA, and several prominent private space companies. The assembled experts, with faces etched in determination and hope, presented a unified vision. Mars was no longer a passive target of colonization, but a partner in a grand cosmic adventure. "This discovery is our invitation," proclaimed one of the spokespersons, his voice resonating with optimism. "It challenges us to rethink everything we thought we knew about planetary habitability. It calls upon us to innovate, to collaborate, and to boldly pursue a future where the energy of a planet itself can sustain human life." The climax of this unfolding narrative was not just the revelation of an active Martian interior. It was the moment when decades of research, competition, and wonder converged into a single, transformative insight. Every observation, Every data, point, and every theory had led inexorably to this turning point. In that moment, the red planet, once seen only as a distant, barren outpost, was reborn in the collective imagination of humanity as a vibrant world brimming with potential. The discovery of the geothermal vents shattered the long-held image of Mars as a static relic of the past, replacing it with a vision of a living, breathing planet that could one day become home to a new branch of human civilization. As the revelations settled in, the mood across the scientific community shifted from cautious optimism to a surge of exhilarating possibility. The race to colonize Mars, once a contest of technological prowess and political will, now assumed a new dimension, one where the very resources of the planet offered hope for a sustainable future. The data spoke a language of renewal and energy, inviting humanity to take a leap of faith into a future where Mars was not merely a destination, but a partner in a cosmic dialogue. In that moment of triumph, as scientists celebrated, and skeptics were silenced by the overwhelming evidence, it became clear that the discovery was more than just a milestone in space exploration. It was a call to reimagine our place in the universe, to embrace the unknown with both humility and ambition, and to recognize that sometimes the most profound insights come from the most unexpected places. In the wake of the breakthrough that unveiled Mars's hidden network of geothermal vents, scientists and engineers have plunged into a realm of exploration that promises to reshape our future in space. This discovery isn't just a fleeting anomaly, it is a transformative insight into the planet's inner workings and its potential to support life in ways we never imagined. To understand its importance, one must first grasp the concept of geothermal activity. On Earth, geothermal energy comes from the heat stored in our planet's interior, which powers natural phenomena like geysers and hot springs. Similarly, the vents on Mars represent channels through which heat and possibly even water from deep within the planet are transported to the surface. These vents are not only a sign of an active interior, but also suggest that Mars may harbor reservoirs of liquid water or other volatile compounds, which are essential ingredients for life. At its core, the discovery challenges the long-standing perception of Mars as a cold, static world. For decades, Mars was thought to be a dead planet, a barren rock with a thin atmosphere and a history of volcanic and water activity that had long since faded. The detection of these geothermal hotspots, however, hints at a vibrant, dynamic system operating beneath its rugged exterior. Advanced instruments on orbiters and landers have measured subtle variations in temperature and magnetic fields, confirming that these vents are not sporadic but part of an extensive network. This network could be likened to a planet-wide circulatory system where heat and possibly life-sustaining elements are transported from the deep interior to the surface. The implications of tapping into this natural energy source are profound. For one, these geothermal vents could provide a renewable and sustainable source of heat and power for future Martian colonies. Imagine habitats built near these vents, where the natural warmth reduces the need for heavy, energy-intensive heating systems. This could be a game-changer for colonization efforts, as it offers a way to create a self-sustaining environment in a place where traditional energy sources are scarce. Engineers and architects are already brainstorming designs for structures that would integrate with the Martian landscape, using the planet's own energy to maintain life support systems and facilitate industrial processes. This vision of a self-reliant colony, powered by the planet itself, brings us a step closer to turning the dream of interplanetary living into reality. The discovery also propels forward our understanding of planetary evolution and habitability. The active geothermal system suggests that Mars, like Earth, might have maintained pockets of warmth over billions of years, a crucial condition for life. On Earth, Some of the most resilient forms of life thrive in extreme environments, such as the scalding waters of deep-sea vents. These organisms, known as extremophiles, survive by harnessing the energy and chemicals provided by their harsh surroundings. If similar conditions exist on Mars, it opens up the tantalizing possibility that life, perhaps in microbial form, might have found a way to persist, hidden beneath the surface. This prospect not only redefines our search for extraterrestrial life, but also adds a layer of urgency and excitement to future missions to Mars. The notion that the planet could still harbor life, albeit in isolated niches, challenges our understanding of where and how life can exist. From a scientific standpoint, the study of Mars's geothermal activity offers a unique opportunity to test and refine theories about planetary interiors and magnetic fields. The process by which heat moves from the interior to the surface of a planet is complex and influenced by a host of factors, including composition, pressure, and the presence of liquid water. By examining Mars's geothermal vents, researchers can compare these processes to those observed on Earth, gaining insights into the similarities and differences between the two planets. Such comparisons not only enrich our knowledge of planetary science, but also help us understand the potential future of Earth's own geological activity as our planet evolves over time. Furthermore, this discovery fuels a broader conversation about humanity's role in exploring and interacting with other worlds. With Mars suddenly revealed to be a more dynamic and resource-rich environment than previously thought, the race to establish a human presence on the red planet gains a new layer of significance. It's no longer merely a contest of technological achievement or political prestige. It's an opportunity to learn from and harmonize with the natural processes of another planet. The geothermal vents present both a practical resource and a symbol of nature's underlying power, urging us to consider how we might coexist with, rather than dominate, the environments we explore. As researchers continue to analyze the data and refine their models, every new insight brings us closer to unlocking Mars's mysteries. The discovery of these vents is a reminder that space exploration is not just about reaching distant targets. It's about understanding the complex interplay of forces that shape worlds, including our own. In this spirit, the breakthrough on Mars serves as both a scientific triumph and an invitation to dream bigger. It challenges us to push the boundaries of our knowledge and to envision a future where humanity not only inhabits other planets, but learns to live in harmony with their natural rhythms. Ultimately, Mars's hidden geothermal network may be the key to a sustainable future in space, offering hope and a pathway toward a new era of exploration and discovery. The discovery of Mars's hidden geothermal vents opens a door to possibilities that extend far beyond scientific curiosity. It holds the potential to reshape humanity's future in profound ways. On one hand, this breakthrough promises immense benefits, fueling optimism about sustainable space exploration and even revolutionizing our approach to energy on Earth. Much like the discovery of electricity, which transformed everyday life by powering homes and industries, harnessing Mars's geothermal energy could spark a new era of technological innovation. Future colonists on the red planet might build habitats that tap directly into these natural heat sources, reducing the need for cumbersome and energy-intensive life support systems. This self-sufficiency would not only ease the logistical challenges of living on a distant world, but also set a precedent for sustainable off-world living, a blueprint that could inform how we approach resource management on our own planet. Beyond the technical advantages, the discovery carries a symbolic weight. It challenges the long-held image of Mars as a lifeless, barren rock and redefines it as a dynamic, living planet with untapped potential. This shift in perception is crucial because it alters the narrative around space exploration from one of conquest and exploitation to one of partnership and coexistence with nature. It invites humanity to reimagine our role in the cosmos. Instead of imposing our will on alien worlds, we might learn to work with the natural processes that govern them. Such a paradigm shift could lead to more ethical and environmentally sensitive approaches to colonization and resource extraction, ensuring that our expansion into space is guided by respect for the intrinsic value of these celestial bodies. However, the implications of this discovery are not solely positive. The unveiling of an active geothermal network on Mars also raises a host of ethical, political, and environmental questions that we must address before proceeding. One of the most significant concerns is the risk of unintended consequences when interacting with a complex planetary system. Just as human activities on Earth have sometimes led to ecological imbalances, any attempt to tap into Mars's geothermal energy might disrupt delicate subterranean processes that have evolved over billions of years. The potential for triggering unforeseen geological shifts or destabilizing local ecosystems poses a serious challenge, one that calls for cautious and well-planned exploration strategies. Furthermore, the competitive rush to claim these newfound resources could exacerbate geopolitical tensions. The race to colonize Mars is already a high-stakes contest among nations and private enterprises, and the promise of a natural, renewable energy source could intensify this competition. History has shown that the discovery of valuable resources, such as oil or rare minerals, often leads to conflicts and power struggles. In a similar vein, the scramble to harness Mars's geothermal energy might not only pit countries against each other but also create divisions within the scientific community, where collaborative efforts risk being overshadowed by nationalistic or corporate ambitions. The long-term consequences of integrating Mars's geothermal systems into human technology remain uncertain. While the potential for clean, abundant energy is exciting, the challenge lies in developing technologies that can safely and efficiently harness this energy without compromising the planet's natural state. This uncertainty serves as a reminder that every technological leap comes with its own set of risks. It underscores the need for robust international regulations and collaborative frameworks that balance innovation with preservation, ensuring that the drive to explore and exploit new resources does not come at the expense of ethical and environmental stewardship. In the end, the discovery of Mars's geothermal vents is a double-edged sword, offering both transformative opportunities and significant challenges. It embodies the very essence of exploration, the pursuit of knowledge that carries the promise of progress, but also demands humility, responsibility, and foresight. As we stand on the brink of a new chapter in space exploration, the choices we make today will echo far into the future, shaping not only the fate of Mars colonization, but also our broader relationship with the cosmos. As we conclude this remarkable journey into the heart of Mars's hidden secrets, we are reminded that every discovery in space is a mirror reflecting the vastness of our own potential. The unveiling of these geothermal vents is not merely a scientific milestone, it is an invitation to reimagine our place in the cosmos and to embrace the unknown with both wonder and responsibility. This discovery challenges us to see Mars not as a barren frontier, but as a dynamic world, pulsating with energy and possibility, a partner in our shared quest for knowledge and survival. Now, as you gaze upward at the night sky, consider the endless mysteries waiting to be uncovered. Each star, each distant planet, tells a story of transformation and hope, urging us to explore further and dream bigger. Let this moment be a call to action, to question, to learn, and to remain ever curious about the universe that cradles us. Join us in this grand adventure. Subscribe, share, and continue exploring the cosmic narrative that connects us all. The next chapter in the story of space is being written, and your curiosity is the spark that will light the way.